When psychologists started looking at human development, we originally looked at human development as something that happens between birth and the end of puberty. Now, that's no longer the case. Now, when we look at human development, we start at conception and we actually end with neuron death. That is, we end at the point when the brain no longer functions, the point when it's medically impossible to bring a body back. Human development is a varied and complex path, and so it requires a lot of different disciplines working together to make it happen. When we start looking at human development, we have two dichotomies in a way. The first of these is the nature versus nurture argument. When we look at nature versus nurture, it's important to remember that your nature is everything you're born with. Everything you have the moment you're born. Essentially, it's your DNA and nothing else. That's the only thing that represents your nature. Everything else is nurture. Your mother's diet while you're in the womb even. Your diet upon leaving the womb, whether you are fed breast milk or formula, what kind of schools you get into, how well off is your family. All of this is nurture, everything that you're exposed to beyond your genetic identity. Then we have also qualitative versus quantitative change. And this is simply a way of looking at how we develop over time. Qualitative change is usually considered a stage-wise or a stepwise way of looking at development. And humans don't really develop in a qualitative way. We grow in a smooth linear transition in this quantitative or continuous way. But qualitative changes are easier to define and easier to discuss. So we'll be looking at a couple of examples of qualitative change and one or two of quantitative change as well, and getting a little bit more into hopefully some examples of how those work so that you can see the difference between them. Human development is interesting in the field of psychology because you can't often do an experiment that lasts for a day or a week or a month and sort of have a one-time shot at all of your participants, because the changes that happen through human development take so long to develop. So we actually have a couple of research designs that work reasonably well to study human development. The first of these is cross-sectional research, and the second is longitudinal research. We'll look at each of these in a little bit more detail. This is how they work essentially. The cross-sectional design, if you wanted to study age-related differences, you could get, for instance, a group of 30-year-olds, a group of 60-year-olds, and a group of 90-year-olds. And you could test them all at the same time. If you wanted to do a longitudinal design, okay, you would gather a group of 30-year-olds, test them, and then wait 30 years and test them again when they're 60, and then wait another 30 years and test when they're 90. Now, the obvious flaw in the longitudinal design is how long it takes, versus the cross-sectional design, which takes a very short period of time. However, the cross-sectional design is a lot faster than the longitudinal design. And that works really, really well, for instance, for short-term projects, for college-level projects, that sort of thing. The cross-sectional design is excellent. However, with the cross-sectional design, there's no way to control for what we refer to as cohort effects. In essence, today's 30-year-olds are not the same as today's 90-year-olds. Today's 90-year-olds went through Korea, they went through Vietnam. Their parents, their parents would have gone through World War II. Maybe even big siblings might have gone through World War II. These 90-year-old individuals are dramatically different. They're from a different generation. They're from a different mindset. They have different ideals. And so the cross-sectional design can absolutely give us a great view of the differences between these generations, but they have a much more difficult time showing us how humans actually develop. And so, in order to eliminate that, we use the longitudinal design, which does take an extremely long time, and it's extremely costly. But it eliminates all of these cohort effects because you're testing the same cohort, the same group of individuals over a period of their lifetimes. Okay? Now the problem with the longitudinal design is that you do have to wait for a long time. You have participants who die, you have participants who drop out, participants who move, participants who change. They don't want to participate anymore, they can't participate anymore. All sorts of things can happen, even in a relatively short-term longitudinal design. That's happened perhaps over 10 years as you study the changes going through puberty. Okay. Well, you're going to have participants drop out of a longitudinal design, and therefore your original group needs to be significantly larger than what you need in the end, and that is extremely costly. If you have a really great design, though, something that you're willing to devote the time and money and effort to, you can actually combine the cross-sectional and longitudinal designs into what we call the cohort sequential design. And this essentially combines those two and works them together. So you would begin, and your first wave of research would look like a cross-sectional design, where you have, for instance, in our original idea, you'd have a 30-year-old, a 60-year-old, and a 90-year-old group, just like the cross-sectional design, and you test them all at the same time. So you get this look at the 3 different generations. And then you would wait another 30 years. Now your 90-year-old participants are, for all practical purposes, dead. So you would gather up your 60-year-old participants who are now 90, you gather up your 30-year-old participants who are now 60, and you get a new group of 30-year-olds and test them again. So you have a longitudinal design as well, but you test them again as though they were a cross-sectional design. And you can sort of keep this up forever, constantly getting new groups of 30-year-olds to examine them over a period of time. Cohort sequential designs can theoretically go on forever, with the researcher passing down their research to students or to proteges over a period of time. But again, this is incredibly expensive and incredibly time-consuming. But it also produces an enormous wealth of results, and some of these cohort sequential designs have been going on for a very long time, even in psychology. Now, as I said in the beginning, our study of human development does not begin at birth. Human development begins, even actually before conception, when we look at genetics, right? This is the nature aspect of our human development. And our genetics are based on DNA, that is deoxyribonucleic acid. These are the molecules that contain all of the genetic information, all of the material that makes you you. Now your DNA, the vast majority of your DNA simply makes you human. Only an extremely tiny section of your DNA defines you from every other human. DNA takes the form of these extremely long strands, and it's essentially a sugar. But it is processed, and it has a sequence of encodes on them. And these encodes tell your body what proteins to make, and then those proteins affect how you develop. These strands of DNA can be broken down into individual chromosomes. Okay? You have 23 chromosome pairs. Most people have 23 chromosome pairs. Occasionally, you will have an extra chromosome or even an extra chromosome pair. 22 of those chromosome pairs are identical for everyone, or nearly identical for everyone. The final pair, what we call the sex chromosomes, are typically either XX, which usually produces a female anatomy, or XY, which usually produces a male anatomy. Your genetics do not necessarily define your sex. They do not necessarily define your gender, because there are other aspects. There are hormones, there are other genes that might kick in to alter how your sex is expressed, physically expressed within your body. But those sex chromosomes are generally the markers that we talk about in humans. Other animals have different sex chromosomes that are not the same. When we look at the genes stored within those chromosomes, the genes are the actual codes that produce proteins in your body. We can look at your genotype, okay, which is the sum of all genes that an individual inherits from their mother and from their father. So for each chromosome pair, you get one from your mother and one from your father. The genotype describes the sum total of the genes that you have inherited. However, for most people, most of the time, it's impossible to see your genotype when you look at someone. What you can see when you look at someone is the phenotype, which is the way in which these genes are actually expressed. It shows the observed characteristics of the genes. For instance, what color are your eyes? Either brown or blue. But you can't see necessarily the genotype that has produced that color in the eye. So as I said, we inherit 2 genes for everything, most of the time. Only 2 genes for everything. One from your mother, one from your father. And occasionally, you can get a third, but that usually leads to genetic deformities like Down syndrome. There are 2 ways that these genes can express. Okay, you can have either homozygous or heterozygous traits. In homozygous traits, that means the 2 genes are alike. For instance, you can inherit brown eyes from both of your parents, or you can inherit blue eyes from both of your parents. In this case, these genes are alike, so they are homozygous. Okay? In heterozygous traits, that means that the genes are not alike, so you inherit brown eyes from one parent and blue eyes from the other. In this case, your genes are heterozygous. The genes are not alike. For several human characteristics, it's actually a fairly limited number, only about 1,000 characteristics. We have what we refer to as a dominant recessive pair. We can simplify this and look at eye color as essentially a dominant recessive pair, because there is a dominant recessive pair present. Right? If you inherit a brown-eyed gene from either of your parents, your eyes will express as brown. What shade of brown? That's a little bit more complex, but your eyes will express as brown because that is the dominant trait. And what essentially that means is that you have inherited a gene that produces a protein that causes your eyes to turn brown. If, however, you inherit blue eyes from both of your parents, you never produce that protein that causes your eyes to turn brown. So your eyes will probably turn blue. However, very few human traits are actually dominant recessive, and eye color is not, in fact, a dominant recessive trait. There are a lot of variation within other aspects of those proteins that can produce, for instance, dark brown or light brown. They can produce blue or gray or hazel eyes. Okay? But there are some traits that are dominant. Having brown eyes, having dark hair, having curly hair, having normal hearing, that is being not deaf, having normal vision, that is having no color blindness, being polydactyl, so actually having 6 or more fingers on each hand is a dominant trait. Fortunately, it's a rare mutation. Most of your traits are codominant or additive. That is, a number of genes interact to form a specific trait. The exact shade of color in your eyes or in your skin, how tall you can possibly be, your average weight when you're an adult, exactly when you will enter puberty. All of these things are codominant or additive traits, where you have multiple genes that all interact to produce exactly your facial structure and exactly the size and shape of your hands and so on. All of these traits are very, very complex and far more complicated to look at than these dominant and recessive simple traits. And we refer to these also as either discrete or polygenic. Okay? A discrete trait has a single gene pair, again, this is very rare, versus polygenic traits that combine the impact of multiple genes to produce either your appearances or behavior patterns even, because we do have some behavior patterns that appear to have a genetic component. Human development begins with conception. And conception is the moment that sperm meets egg and the two half DNA patterns merge into one. We begin essentially with the human ovarian duct, okay, which an egg cell is released from the ovary into the fallopian tube. And the fallopian tube begins to move that egg cell toward the uterus. At some point, usually inside the fallopian tube, sperm will intersect with the egg, assuming that conception is going to happen. Sperm intersect with the egg, fertilize it, and begin to create cells. Now, the egg is actually extremely large for a cell, so large that you can actually see it without a microscope. And it's necessary that it's that big because for about 2 weeks during this germinal stage, the egg cell has no way to acquire more mass, and it has no way to acquire more energy. So it has to have all of that mass and energy stored already in it for 2 weeks of life and cell growth. And we begin with this fertilized egg inside the fallopian tube, and it begins to divide, and it begins to divide very, very rapidly for about 2 weeks. And during this time, you get a zygote, which is simply, it's a ball of cells. Okay? And there's really nothing else to it, and it's floating, essentially free floating. So this germinal stage begins with conception and ends at the moment the egg cell touches a viable portion of the uterine lining and implants. Once it implants, we enter the embryonic stage. The zygote, now called a blastocyst, begins to develop into an embryo. Embryos don't look terribly human for the most part, but over these next 6 weeks or so, the embryo very rapidly develops. Now, these 2 weeks, this 2-week barrier is actually really important. If you go and look at, for instance, pregnancy tests, they'll tell you that the earliest you can actually test for pregnancy is 2 weeks after conception. This is why. Before the zygote implants and becomes an embryo, the mother's body has no way to know whether or not it has successfully conceived. Okay? Once it implants, the mother's body begins to produce hormones. It begins to alter its structure in order to support and develop the embryo. So, embryo implants, 2 weeks. For the next 6 weeks, all of the major organ systems develop and develop very rapidly. The circulatory system, the neural system that will become the brain, the digestive tract is actually one of the first things that develops in any animal. But it's during this time that the human embryo is most vulnerable to miscarriage and teratogens. Because everything is developing very quickly, any kind of toxin that enters the mother's body could have severe impact upon the embryo. And any major genetic defects, for instance, if the child will not grow a brain or will not grow a heart, these things can cause the child to, what we refer to as spontaneously abort, and you have a miscarriage, And often during this stage, the mother isn't even aware that she had successfully conceived. Her period, her menses, might be a little bit late, and that's all that anyone knows about it. As the embryo gets larger, it becomes more and more obvious when a spontaneous abortion occurs. After week 9, we refer to the embryo as a fetus instead. The fetus does look human. Okay? It no longer looks like a fish or a rabbit or a mouse. Instead, it actually looks human. The tail vanishes during this time. The gills vanish during this time. We begin to develop lungs. We begin to develop eyes. The fingers start to move. All of the things that sort of make us look human develop during the fetal stage. You get an advanced muscular system. You get a skeletal system that is encased in these calcium bodies. And all of the organ systems develop into a functional method so that you can actually use them as you grow. When the embryo implants into the uteral lining begins to produce an organ called a placenta. Now, this is not a picture of a placenta. A placenta is simply an organ that grows on the uterine wall that helps supply nutrients and oxygen and allows the passage of waste, because the child at this point has no way to use the bathroom, right? Can't leave the womb and go to the toilet. So instead, all of that waste is passed into the mother's bloodstream and then excreted from the mother rather than from the child. And then any nutrients that the mother takes in are routed to help this embryo and later fetus grow. The placenta also grows the umbilical cord, which is what actually connects the fetus or embryo to the mother, and that is actually what forms your navel, is the point where the umbilical cord joins your body. The mother does have to pass the placenta after birth. It's necessary to remove the placenta from the body, and it usually just sort of slides out, and the hospital tests it to make sure that it's complete and that there's no problems with it. If you want, most hospitals will allow you to keep the placenta. There's a variety of things that people have done with it depending on culture and belief system, but you don't have to, and it can simply be removed as medical waste. I mentioned the word teratogens as a toxin, and generally teratogens are toxins. They are a substance that causes damage during the gestation of an embryo or of a fetus. Teratogens are not always substances, however, although by far the most commonly considered teratogen is alcohol. There are a great many teratogens, some of which are behaviors, some of which are diseases. So here's a look at some common teratogens. Malnutrition, for instance, is a very common teratogen that affects fetal development. It can cause poor growth and even mental retardation, as the child does not have the nutrients it needs to develop a fully functioning brain. Maternal diabetes, even gestational diabetes, can cause growth abnormalities. That's why mothers are always tested for diabetes, to make sure that they're getting the insulin that they require in order to prevent these growth abnormalities. Many diseases that a mother can have can also be transferred to the child, as well as directly affecting the child's growth. For instance, herpes, HIV, certain forms of cancer, even syphilis can be transferred to the child, not simply in the womb where the placenta might actually filter out many of these diseases, but during the birthing process, when the child is exposed to the genital tissue of the mother, as well as the mother's blood and fecal matter. Now, it's actually important that a child be exposed to the mother's blood and fecal matter during this time, as it produces the first level of, the first exposure to the E. coli bacteria that allows proper digestion, and it's necessary. However, Being exposed to the syphilis uh, organism, for instance, can cause a child to be born with a syphilis infection. It can cause a child to be born with HIV. Uh, so these teratogens don't necessarily affect the child in the womb, although they absolutely can. They can also affect the child during the birthing process. A variety of drugs can also affect the child. Of course, alcohol produces what we call fetal alcohol syndrome. Because we don't know what the pattern is for fetal alcohol syndrome, some mothers can drink a glass of wine every day and have no problems. Others drink only once during their pregnancy and produce a child who has fetal alcohol syndrome. We don't know what the pattern is, and therefore any physician will recommend that you do not drink at all while you're pregnant, because we can't predict what will cause these deformities, both of body and brain. Heroin can actually cause certain diseases, not just heroin, but cocaine as well, can actually cause the child to be born addicted to those drugs. They can cause all kinds of physical and mental side effects as well. Um, Caffeine is actually probably the least dangerous drug that we commonly use as far as being a teratogen. You have to consume a large amount of caffeine at any given time to affect the child. However, in general, you shouldn't drink more than about 3 cups of brewed coffee in any given day. Otherwise, the child may be of low birth weight. And diet pills do exactly what you would expect diet pills to do. The thing is, you want the child to gain weight during this time. It's important, it's necessary for the child to grow appropriately during this time. So taking diet pills does affect your child, because it prevents your child from generating the fatty tissues that are necessary for their appropriate growth. Up until this time, we generally assume that a healthy child, or that all healthy children are essentially the same. However, from the moment of birth, children began to develop extremely rapidly, and very rapidly develop unique, independent, and distinct traits. There are, however, some things that infants all have in common. Uh, Genetically linked growth patterns that exist in all human babies. For instance, we grow what we refer to as a cephalocaudal pattern, which is growing from the head down. The head grows faster than any other part of your body, which really makes sense. You have to accommodate the size of your brain, and because your brain doesn't grow as much as the rest of your body throughout most of your lifespan, it's necessary that it get up to full size fairly quickly so that you can have adequate room to develop all of the complex neural structure that will be necessary throughout your growth. Humans also have a proximodistal growth pattern. That is, we grow from the inside out. The torso grows faster than the arms, legs, or fingers. This is sort of why you have the impression a lot of toddlers, their arms are too short for their bodies. They don't look like adults because their arms and legs are too short. They are. Okay? The torso has grown faster to provide room for all of the critical internal organs that exist within the torso. The arms and legs grow last, and in fact don't even reach full size and strength until after puberty. In general, a healthy child is born with all of the senses that an adult will have. However, these senses are usually not particularly well developed. For the most part, we haven't had to use any of them. So, uh, what we have is a group of senses that aren't they're not adult senses, and they still need a lot of work and a lot of development. However, the sense of vision is by far the worst of the senses at birth. We estimate that a child has about 2,600 vision, which is very legally blind. This vision improves very rapidly over the course of the next few weeks, but this is actually important because 2,600 vision actually allows the child to focus very well at about 12 to 16 inches away from their face. And the reason that that's so important is that 12 to 16 inches is the average distance between the mother's face and the mother's nipple, which provides the child the ability to focus on the mother's face while nursing. This allows the child to bond effectively with the mother. So this development of vision beginning at 2600 is actually very advantageous for humans. Our hearing is somewhat developed. Most children can recognize their mother's voice immediately upon birth, which makes sense, really. The mother's voice has been the thing that the child has been listening to since their sense of hearing became available to them in their development. The father's voice can take a little bit longer, but if the father consistently speaks to the child and consistently speaks to the mother, his voice can be very recognizable as well, the father or the partner, in whichever case. Taste and smell is actually very well developed, with a strong preference for sweet things. Human milk is very sweet, far sweeter than cow's milk. And so we have this preference for sweet things when we're born, and that preference often doesn't go away until well into adulthood. Children can actually distinguish between their mother's milk and anyone else's milk almost immediately, and will show a preference for their mother's milk, assuming that that milk is actually healthy. One of the ways that we examine the visual acuity and the sensory acuity of young children is to use an apparatus like the visual cliff. A visual cliff apparatus actually looks kind of like this, where you have, and then above that you have plexiglass, okay, so that the child can't actually fall. And you would have the baby, for instance, here. Okay. And over here you have mom. Right. So, mom calls the baby over, and you see what the baby will do. And up to a certain age, usually about 6 months, the baby will crawl all the way to mom, indicating that the baby is unaware of the apparent drops that they could actually suffer and will literally crawl off a cliff in order to get to mom. After about 6 months, the baby becomes aware of this shallow area here, and that produces the child can see, right? The child can see depth. The child can see that there's a drop-off there, but they can't necessarily see the smaller drop-off in the shallow area. After about 14 months, the child can see the shallow area, and we can tell because the child will test to determine whether or not it will have that drop, whether or not it needs to crawl down in order to reach mother. Okay, and these apparatuses are used to test depth perception, and they work reasonably well. And it's sort of a fun test, but you can see that visual discrimination begins with our ability to move ourselves, the ability to crawl. And parents, it's one of the things sort of being a parent is when your baby's first starting to crawl, they will crawl directly into the wall and bump their face on the wall because they can't tell how far away it is. So this depth perception, this ability is something that's learned. The ability to determine how far away something is learned, and we learn it by running into the wall a few times in order to determine how far away things are. Newborns generally have no voluntary control over their own muscles, particularly newborns. We're born helpless. We've never used our muscles before. We've never needed to, right? We've always been floating in this nice, safe, warm liquid medium, and we've never had anything that we needed, really. So newborns have no voluntary control over their muscles. Instead, they have a set of reflexes, genetically programmed reactions that are not under voluntary control and are necessary for us to actually develop. The rooting reflex is one of these. If you brush a child's cheek, they will turn their head toward that touch and attempt to suckle. This is important. I mean, this is how newborns eat, is to suckle from the breast. So we brush their cheek, and that causes the suckling reflex. If you touch the palm of an infant's hand, they will close their hand around it. This helps them to hang on. We think that this is actually a vestigial reflex from back when we were related to monkeys, from when we were tree dwellers. It would be necessary to grab on and hang on to branches or to the fur of the mother. So this is sort of a genetic holdover, what we refer to as a vestigial reflex. It's not useful anymore, but it used to be. And there are a great many of these. There's a falling reflex where you extend your arms and legs out. That's another reflex behavior, and humans have quite a number of these reflexes, most of which we grow out of, but a few of them you actually keep. Your response, for instance, to falling is probably still to throw your arms and legs out rather than to tuck, which is actually a little bit safer. Our brains develop extremely rapidly over the course of the first few months, even, of our development outside the womb. We begin with about 2,500 connections per neuron. Okay? We have billions of neurons present in our brain, and we have about 2,500 connections per neuron. Right? That's a very complex network. But by the age of about 2 or 3, you can look at any given neuron and find around 15,000 neural connections associated with any individual neuron. And it only becomes more complex as we get older. This gives us the ability to separate our senses out. It gives us the ability to speak and communicate, to be creative and plan ahead and have these wonderfully complex emotions like love, like passion. It's amazing, right? The complexity of our neural networks, even at such a young age, is amazing. However, of these 2,500 neural connections that are present at birth, we only keep about half of them. Most of the neural connections that occur by the time we're 2 or 3 years old are new. We undergo a process called synaptic pruning. That is the removal of neural connections that we no longer need or that don't serve us very well. We grow more synapses than are necessary at birth, and so we actually prune out a lot of these when we're born. Synaptic pruning does not stop just because we have removed most of these unnecessary synapses. You undergo synaptic pruning essentially for the rest of your life, removing neural networks and information behaviors that you no longer need or that have been conditioned out of you. Synaptic pruning is necessary in order to keep our brains essentially clean for informational development. And we also have synaptogenesis, which is the creation of new synapses, providing more complex neural networks. And this is the process we undergo as we grow more synapses and more complex neural networks. Your nerve fibers also undergo a process called myelination. Your neurons are characterized by a bulb on one end. We call it the cell body, where your nucleus and your DNA and all of your organelles are. And then a long strand coming out of the end, and this is the axon. This is how the signal is transferred from that cell to other cells, is down the axon. The axon undergoes a process called myelination. Myelination is the accumulation of a fatty substance. It's primarily omega-3 fatty acids that develop what we call myelin, a myelin sheath that insulates these nerve fibers. This allows the electrical impulses to travel faster, and it prevents cross-firing and short-circuiting along this axon pathway. The more myelin any given cell has, the faster it transmits. Myelin is actually what gives your brain the white or gray appearance that it has when you remove it and can actually look at it. The more myelin it has, the whiter the tissue appears. So that exterior border, what we call the white matter on the outside of your brain, is heavily myelinated tissue versus the gray matter beneath, which is slightly less myelinated, and therefore the signals move a little bit more slowly. Myelination is a very long process that begins at the base of the brain, right at the connection of the skull, and moves up and forward, ending in the prefrontal cortex during puberty. When we're born, we very quickly develop what we refer to as attachment, which is an emotional bond between parent and caregiver. Your first attachment is almost always to mom, but any other caregiver can begin to develop an attachment with the child very quickly. Attachment is almost always a two-way street, although not necessarily. Harry Harlow gave us a lot of experiments on this form of attachment using rhesus monkeys and these artificial mothers. What he showed was that, or what he did was he got these two artificial mothers, and he had one that was just a wire cage you can see with a milk bottle, and then the other one was a felt mother that actually was warmed from the inside, so it wasn't just a piece of cold felt. And what he found was that the monkeys would go, when they were hungry, they would go to the mother that fed them, this wire cage, but then they would immediately return to the felt mother, to this warm, comforting touch. Even when the monkeys were startled and frightened, they would immediately return to the warm, comforting touch of the felt mother, and then begin to threaten the source of their anxiety. He actually invented a little mechanical monster that would produce anxiety in these monkeys, and they would begin to threaten this device after they had established that they were safe with their mother. The strange situation test is a way of discovering how attachment has developed between a mother and child. You bring the mother and child into a strange room with strange toys. This is actually important, and allow the child to play with the toys for a little bit. And then you can go through several different kinds of ways of looking at this process. But one of the most common ways is that the mother will leave, and then you have a stranger come in. And you see how the baby reacts, both to the mother leaving and to the stranger. And then you have mom come back and talk to the stranger and see how the baby reacts. And then you have the stranger leave and see how the baby reacts. And this produces an observation of exactly how the child has attached to the mother, and a sort of a sequence of responses and response patterns that the child has. And we can categorize these as different forms of attachment. Most children have a secure attachment with their parent. And what a secure attachment means is that the infant will usually be distressed when mom leaves, but not overly so. They're upset, they don't want mom to go, but they have a confidence and a trust that mom will come back. She's not gone forever, right? And even when they're about 2 years old and they have separation anxiety, the child will eventually get over mom having gone and will continue to play with the toys. Securely attached children may investigate a stranger, but usually won't get too close. And then when mom comes back, a securely attached child is excited to see mom when she returns. Will hug and return to that essentially safe base that is mom. We can also describe several kinds of insecure attachments. Avoidant children, for instance, will show almost no distress at separation and very little joy at the reunion. They won't check back with mom. They won't look back at mom while they're playing. They won't come back to mom. And so we refer to this as an avoidant attachment style. An ambivalent attachment style may show several mixed reactions. They may become extremely distressed at separation, but they don't know necessarily how to respond when mom comes back. They may respond to different strangers in different ways. And thus we have what we refer to as an ambivalent, where the child is both very strongly attached and also shows signs of avoidance of attachment figures. Disorganized is a fairly large segment of the insecure attachment as well, where the child's behaviors are extremely unpredictable and may even respond with violence toward mother when she returns, being upset that she left to such a degree that they may actually attempt to attack their mother. When we look at attachment styles, we can also look at parenting styles, and various parenting styles produce various attachments. Almost always, the best form of attachment that we can develop and the best long-term outcome for children is using an authoritative parenting style. This is also the most complex and the most difficult parenting style for many parents. The authoritative parent is emotionally warm to the child. They're sensitive to the child's needs and very responsive. If the child asks a question, the parent will pay attention to the question and attempt to answer the question in full. These parents make reasonable demands of the child. So, for instance, demanding that a child get straight A's all the time is not an authoritative parenting style, but demanding that a child do their best, study hard, attend classes appropriately, is a form of authoritative parenting. Authoritative parents also have rules that make sense. The rules don't change a lot, but those rules are subject to adaptation. They are subject to negotiation, even with the child. All right, and these rules encourage appropriate autonomy and appropriate behavior from the child. More importantly, the child knows why those rules are in place. Very rarely, I don't say never, but very rarely will an authoritative parent have to say, "because I said so." Instead, most of the time, these parents are able to explain their rules. There's a reason for it. Don't run out into the street. Okay? Don't run out in the street because it's dangerous, because the cars won't necessarily be looking for you, because the cars won't necessarily understand what you're about to do. Instead, be sure that you look both ways, and so we have these rules that make sense. Occasionally, authoritative parents do have to say, "because I said so," because they don't have the time or energy to explain the rule right then, but can explain it later. Authoritative parenting produces children who have high self-esteem, high autonomy. They're able to cooperate with other students. They tend to have very good self-control and social maturity. Indeed, children of authoritative parents have a tendency to challenge the rules when they don't make sense and be able to establish a new set of rules that accomplish the same thing but do make sense. The children of authoritative parents will also set punishments for themselves when they do break a rule. They'll set punishments for themselves that are often more harsh than what the parent would have set as a punishment to begin with. Authoritarian parents, not to be confused with authoritative, authoritarian parents are emotionally cold and rejecting of their children in generally. They tend to make coercive demands and often will use the phrase, "because I said so," when explaining their rules. Their rules are coercive, harsh, and may change almost at random. And they're frequently very critical of the child. When we think of an abusive parent, we often think of an authoritarian parent. But authoritarian parents don't just come in what we would consider a traditionally abusive parent, where you have perhaps a parent who would beat or attack their child for whatever reason. The authoritarian parent may also appear in the parent who demands straight A's at all times, who demands that the child maintain perfect discipline, perfect attendance, with no variance and no room for compassion or mercy on the child when they mess up or have a bad day. Authoritarian parents tend to produce children with very low self-esteem who are very anxious and unhappy. And these children have a tendency to begin using the violent methods that their parents have used to control them. They use these same violent methods to control their peers and younger students as well. Permissive parents are generally warm and accepting of their child, but often overindulgent and inattentive. The parents who try to be their child's best friend are usually permissive parents, and it doesn't take much to see a permissive parent. You can go to Walmart and see them. When you look down the aisle and there's a parent saying, "Please don't do that. Don't do that, honey. Come on. You know better than to do that. Please don't do that." And nothing ever happens, nothing improves, and and everyone else in the store hates this kid. Okay? That's a permissive parent. There are no rules, or when there are rules, they're not enforced. There's no punishment for breaking the rules. There's no encouragement for behaving appropriately. And as a result, you get these very impulsive and disobedient children who are constantly searching for the boundaries of their behavioral limits. Children want boundaries. They want to know what's appropriate, even if they can't express it that way, even if they don't feel that way necessarily. It's part of their emotional makeup to be looking for boundaries, to be looking for limits to their behavior, and permissive parents don't give them that, which produces very difficult children. Uninvolved parents are usually emotionally detached, often depressed, often but not necessarily depressed, and have very little time or energy for their children. There's a variety of reasons to be an uninvolved parent. If you're working 3 jobs, it's extremely difficult to be an involved parent. It's very difficult to be emotionally invested in your children as much as you would like to be. And this is simply, you don't have the energy, right? Also, a spouse who is being abused will often be an uninvolved parent because they can't function that way. But there are a lot of reasons to be an uninvolved parent that aren't simply being a bad parent. But this uninvolved parenting style leads to anxious children who have often very poor communication skills because they aren't being taught how to communicate their needs, their wants, their desires, their feelings, because the parent can't communicate these things either. For a long time, we believed that fathers were not particularly important in a child's development. In fact, if you look, for instance, at the Disney movie of Mary Poppins, when the father comes in, and he even has like a song about it, how he comes in, he sees his kids, he pats them on the head, he sends them to bed, and that's all the interaction he has with his kids. At that time, they thought that was normal. They thought that was perfectly fine for a father-child relationship. Now we know that that's no longer. We know that that's not the case. Instead, we can see how much children need that second parent. It produces this powerful positive effect on children. We know that children who interact with their fathers a lot tend to have higher IQs. They do better in their social relationships. They cope with frustration better. And most of this is simply because when they have a problem, they persist longer in solving that problem. They try harder. They look for different ways around solving the problem instead of seeking outside help. They're far more likely to persist in solving the problem because that's part of what fathers teach. Children who interact with their fathers are also far less impulsive and far less violent. Unlike what you would think, where the father might teach the child more violent behavior, they actually teach the child less violent behavior. Also, the father-son relationship is passed down. So the better father that someone can be, then they teach their son to be a better father, and then their son can be a better father to his son, and so on down the line. So it's actually an enduring thing to be a good father, is to pass down and have your son be a better father as well. Fathers do interact with their children differently than mothers do. They tend to engage in more exciting and more arousing play, while a mother will hold the baby in their arms and sort of bounce it a little bit and be like, oh, 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 here we go. Dad will throw the baby in the air and catch him. You know, it's this more exciting, more physical play that fathers engage in. Mothers are far more likely to cushion against overstimulation and injury as well. You can sort of see this. You run to the park and you can see, you know, oh, well, a kid comes up with a skinned knee, mommy, 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 and mommy brushes it off and kisses it and puts a bandage on it and makes it all better. And dad's going, well, it's not broken, you're fine. Right? The father is not ignoring this injury, but rather the father is teaching the child to be able to overcome the discomfort from the injury and continue to have fun. Fathers are also more supportive of a child's confidence and individuality and remain physically further away. This is one of the things that I love about taking my kids to the park, is that I can really observe this kind of behavior. You have moms will patrol the park. They walk through and their heads are on a swivel, constantly watching not just their kid, but everybody's kids, and monitoring them all the time, while his dad's sitting back against a railing at the edge of the park reading. You know, and it's not that the father is ignoring the child, but he's giving the child a bigger opportunity to play, a bigger opportunity to get hurt, a bigger opportunity to deal with frustration. And it gives the child a different perspective that mom can't or won't necessarily give. Now, most of our research is still on heterosexual couples, on mothers and fathers. What we know is that there is still something of a hierarchy. We're having two loving, cooperative, authoritative parents is better than having one parent. And it doesn't matter what gender pair those parents are, whether it's heterosexual or homosexual, it makes no difference. However, having one parent is still better than having two parents who are constantly at each other's throats. Staying together for the sake of the child is not beneficial. Rather, it's actually more beneficial for the parents to be able to split up and hopefully have an amicable and cooperative divorce where they can both take care of their children in different ways than it is to stay together supposedly for the sake of the children and be constantly fighting. As children grow, they continue to change physically, cognitively, and socially as well. So let's look at some of those aspects. As we grow into childhood, our gross and fine motor skills improve dramatically. Being able to walk, to kick a ball, to write with pen and paper, right? Walking and kicking a ball is an example of gross motor skills. They require large muscles and large motions. Whereas being able to speak, to write with a pen, those sort of things are fine motor skills, requiring very delicate motions from very small muscles. The association regions of the brain continue to develop, so you can associate different sensory inputs. We're constantly changing, right? Our sense of taste is changing, so the things that you like to eat change over time. And with children, this is particularly true and changes particularly quickly, right? This also allows for problem solving and planning skills, and the brain continues to myelinate throughout childhood. If you recall, when we discussed the idea of parallel distribution theory concerning human memory, we talked about schema. And this idea was given to us by a psychologist named Jean Piaget, who talked about the schema or the schemata as mental frameworks for organizing information within a child's world. And we put all of our information into schema so that we can understand and organize that information. When we acquire new information, we have a choice. We can either assimilate or accommodate that information. For those of you who have watched Star Trek, you can look at the Borg, and the Borg talk about assimilation and how they're going to assimilate these other cultures. And what they're doing is they're altering and changing those other cultures to fit what is already present within the Borg collective. When you assimilate information, that's essentially what you're doing, is taking in information and then warping it, changing it, and forcing it to fit the schema that is already present within your own mind. Assimilating information is the easier of these two processes, but it also tends to produce false or dogmatic forms of belief because you have assimilated information, you have altered it to a form that is not necessarily true. Accommodation is a more appropriate way of dealing with new information. It is the scientific way of dealing with new information, where we either create new schemas or alter existing schemas to fit this new information that's incoming. Now, you don't, of course, want to accommodate false information. So when you're accommodating information, it's important to be able to verify the information and accommodate the truth. Okay? But accommodating information is more difficult and it's more uncomfortable, and you have to get used to it. And you have to get used to sort of accommodating by default, and it's something that you have to train yourself to do. In either case, when you assimilate or accommodate information, the goal is to achieve equilibrium, where all of the information is organized into schemas, and those schemas work. They're in balance. They're in a state of equilibrium. When you're not in equilibrium, you experience what we refer to as cognitive dissonance. That is, when you have information that doesn't fit your schema, you experience cognitive dissonance, and you seek equilibrium by either assimilating or accommodating that information. Jean Piaget also gave us a stage-wise or a qualitative map of human development and how humans learn and how humans think. Okay, so it's very much a cognitive map of human development. And he began with a sensory motor period. This is between about birth and 2 years old. All of the information that we take in and all of our ability to manipulate the world outside of ourselves deals with our senses and our motor actions, hence a sensory motor period. Okay? This explains why we put things in our mouth. Infants put things in our mouth because the mouth has some of the most delicate sensory nerves in the human body. We learn by grasping, we learn by sucking, and we learn eventually by looking and by taking in this sensory information and by physically manipulating the world around us. This is how we work with the world around us. During this period, we begin to learn the idea of object permanence, the idea that an object exists even when it's unseen. This is why very young children love the game of peekaboo, where all of a sudden, oh, mommy's gone, wherever did she go? And then she comes back. Yay, mommy's back. Well, we know that you didn't go anywhere. You just put the blanket over your head. But the child doesn't know that. As far as the child is aware, you're gone. You vanished. Okay? Because they don't understand object permanence. And object permanence grows over a period of time. It's not a sudden realization. There's no big aha moment associated with object permanence. But it's a cognitive task that we learn to become aware of the idea that just because an object is not presently available to the senses does not mean that the object is gone forever. As we grow and our cognitive abilities develop, we begin to be able to work with operations. An operation is the ability to concentrate and manipulate ideas within the mind. The pre-operational stage, that is the stage in which we are beginning to learn how to manipulate objects in our mind, is between about the ages of 2 and 7. But remember that just because a child turns 2 years old doesn't mean that they're suddenly in the pre-operational stage. Rather, we grow and develop smoothly from this sensory motor period into the pre-operational stage. And in some cases, we never really lose some of the traits that we had in the sensory motor period. When we see something that fascinates us, we want to touch it. You go to the museum, for instance, and you see the dinosaur bones or what have you, the statues and the artifacts. You want to touch them. You want to make them real. That's sort of an artifact of this sensory motor period, and it never goes away. But the pre-operational stage represents that the child is beginning to learn to have mental representations of objects. So one of the most obvious examples of pre-operational thought is words, being able to speak, because each of our words is a representation of something else. It's a symbol that means another thing. And it's necessary to have at least pre-operational thought in order to begin to develop the ability to speak. Kids during this period often get problems wrong because there are things they have difficulty doing. Things like reversing an operation. Preschoolers have a tendency to think that things cannot be reversed. Once you've added something, it's difficult to subtract that thing because they can't imagine being able to reverse a process that's already occurred. They also experience what we refer to as egocentrism, which is not to say that they're arrogant or stuck up or anything, but rather that they have an inability to determine that just because they think a thing does not necessarily mean that other people think a thing. Egocentrism is something that children of this age explore actually a lot. And we can see their exploration of egocentrism in the act of lying. As children begin to learn to lie, they begin to learn to deceive, they begin to learn that other people can believe things that aren't true. If I tell you something that's not true and you believe it, that tells you that I can know things that you don't, right? And that is sort of an example of how we break out of egocentrism as being aware that other people can believe something that's not true. Okay. And conservation occurs in a variety of environments, but it's the inability to realize that objects stay the same despite a change in appearance. Things like this orange juice example, where the child sees that two glasses of orange juice are identical, but when you pour one of those glasses into a tall, thin glass, it looks like more because the level of juice is higher. So the child will choose the glass that is taller and thinner because it appears to have more material in it. That's a form of conservation. As we continue to grow and develop our ability to use operations, we begin to develop the concrete operations first. The ability to manipulate solid or defined objects and problems in our head. Okay? They tend to be limited to concrete and real-world objects, being able, for instance, to add and then eventually to multiply are concrete operations. This is why, for instance, you can't teach an 8-year-old calculus. It's not possible. The child is not capable of processing information in that way because the brain hasn't physically matured into that ability. Even though you still have to teach them at some point, you don't miraculously gain the ability to do calculus. A child at this age doesn't have the maturity and the physical development necessary to process information that way. Concrete operations allow a child to solve problems in their head, to manipulate real-world objects, to deal with all these sort of physical concepts. The formal operational stage begins around puberty, where these young adults begin to develop the ability to think about hypothetical situations. They begin to be able to really start asking the question, what if? Okay? Which is a question children can't adequately answer. They can't think about things that aren't real very well because they're still dealing with these concrete operations. Formal operational thought begins our ability to deal with hypothetical situations, the ability to plan ahead, the ability to make contingencies. There are some sort of problems with the formal operational stage, particularly in the beginning, where children develop, or young adults rather, develop naive idealism, where they think they can solve a deeply complex problem with a very simple solution. And you can see some of these examples cropping up now where we have, for instance, Mr. Trump producing all of these these proclamations in an attempt to solve what he perceives as world problems, and he's making it worse. It's a form of naive idealism, and overcoming naive idealism requires a lot of exercise and a lot of cognitive exercise, education, and the ability to use formal operations in a complex way. Whereas people who don't develop these skills, and a lot of people don't ever develop these skills because they don't deal with these processes on a daily basis. They don't have the cognitive exercise and the intelligence necessary to really use these formal operational thoughts. Okay? Imaginary audience is another example of a problem with formal operational stage. Teenagers often believe they're being watched all the time, and that minor mistakes will be remembered and laughed at forever, whereas most of the time they're not. Other people forget our problems or don't even notice them because they're too wrapped up in their own imaginary audience. But children, or young adults rather, have a lot of anxiety because they believe, oh, well, I tripped over my shoelaces, people are going to laugh at me forever. Nobody else noticed, right? It's an imaginary audience. It's not real, but it's very real to that young adult, and most people do grow out of it as they age. So while Piaget gave us this stage-wise cognitive development, Vygotsky gave us a smooth, quantitative, sociocultural theory. There are no stages in this theory. Rather, what he gave us was a way of looking at child learning and development in a very smooth sort of fashion. And he talked about what he called the zone of proximal development. If we look at, for instance, addition, the zone of proximal development begins at a very young age, right around 5 to 7 years old, commonly. And this is when a child can begin to learn the process of addition. But the child can't do addition by themselves at this stage. They're not mature and developed enough to actually do this process. Instead, they need a lot of support. You set a child down and you say, all right, this is 2 plus 2, and this is how we're going to do it. We take 2 pennies, and you set those pennies in front of them. And then we take 2 more pennies, and you set those pennies in front of them, and you say that this is 2 plus 2. And we push those pennies together, and we count them all up, and we get 4 pennies. And that's the beginning of the zone of proximal development. And as this zone of proximal development progresses, soon the child can begin to set the pennies out for themselves and count them and combine them. And then they can set the pennies out and they don't need to combine them so much. They just need to count them. And then they don't need the pennies so much. And they count on their fingers. And then they can start doing it in their head. And then they do it automatically. That's the zone of proximal development, as they need less and less and less supervision and support. And what he referred to, that supervision and support, is referred to as scaffolding, where the adult or the teacher, the parent, sets up a scaffold to support the child's learning and development of a given skill, right? And as the child progresses and becomes more and more skilled at this process, they can take that scaffolding down until it's no longer needed, right? At which point the zone of proximal development for that task ends. But there's a zone of proximal development for every task where you need scaffolding at the beginning. And even adults have a process where you need scaffolding. If you want to teach yourself a musical instrument, you might get a musical instrument. And we begin with scaffolding, either by hiring a teacher or looking up things on YouTube and getting books and learning about it. And we develop sort of our own scaffolding by doing that, because as an adult, we're capable of doing that. And then as you get more and more and more skilled, you take that scaffolding down until the minimum necessary. Learning a musical instrument, you might still need to look at the music, which is still a form of scaffolding. And you may never get away from having to look at the music. But you don't necessarily need, for instance, a fingering chart to be able to determine what the chords will be. Another specific stage-wise theory of human development was Kohlberg's theory of moral development. And he wanted to look at exactly how humans develop our moral and ethical codes. He wasn't interested in what those codes were, but in how the decision-making process worked. And he did this by developing designs like this. Okay? He would tell this morally ambiguous story and then ask the question, what would you do? But more important than what would you do is, why would you do it? Because that's the process of coming to the conclusion. And things, for instance, like with the Heinz and the drug story, it's impossible to say necessarily which of the choices is morally correct. What you can say is, how complex is your decision-making process? And he gave a set of ideas for how those decision-making processes can actually be engaged in. So when you read Heinz and the Drug, keep in mind why you would make the decision more than what the decision is. The first stage of Kohlberg's moral development theory, he referred to it as the pre-conventional moral reasoning. And essentially, morality centers on what you can get away with or how you will be directly punished for your behavior. It is essentially the behaviorist view of moral development. For instance, Heinz should steal the drug because he can get away with it, because he can, right? Or he should not steal the drug because he would go to jail. Okay? Or he might, yes, he should steal the drug because then he'll have his wife and that's a reward, right? The pre-conventional moral stage deals with reinforcement and punishment. Okay? It doesn't even deal with society. It deals with reinforcement and punishment. The conventional moral reasoning is where morality centers on avoiding others' disapproval or with obeying society's laws, okay? So he should steal the drug, for instance, because if he didn't, then people would think he's a terrible person and he would be ashamed, okay? Or if he does steal the drug, it's a criminal act. He would be going against the law and he shouldn't do that, okay? That's conventional moral reasoning. Post-conventional moral reasoning, according to Kohlberg, deals with abstract ethical principles, universal justice, okay, or self-actualization, determining the kind of person you want to be, right, is part of post-conventional moral development. So he should steal the drug because the druggist was being unjust. It is right to break the law to save a human life. Okay? Or he should not steal the drug because by stealing it he would have broken his own moral standards and by doing so would have let himself down. So that's Kohlberg's theory of moral development. Like so many of these theories, Kohlberg's theories of moral development have been challenged, not necessarily revoked or debunked, but certainly challenged and developed over the next few years. And one of the big reasons for that is that Kohlberg believed that girls had a weaker moral development than boys did, that girls could never achieve post-conventional moral reasoning. A female psychologist, of course, Carol Gillian, challenged this and said that boys and girls' moral reasonings do differ, but the complexity and the sophistication of the moral reasoning is equal. Okay? What she said is that boys deal with justice and morality and self-actualization, whereas girls put more emphasis on relationships, they put more emphasis on abstract ideas, on love, on compassion, rather than on equality and justice and mercy. Okay? So their moral reasoning is different, but no less complex. And Carol Gillian's reasoning has absolutely been supported by cross-sectional research over the years. It shows that people from, for instance, collectivist cultures actually score higher than people from individualistic cultures. So actually cultures that place more emphasis on relationships, more emphasis on abstracts, are more emphasis on relationships and mercy than on justice and equality, actually score higher. Okay? So in some ways, the female version of this moral development sequence is more advanced than the male version of this sequence. As we continue to develop, we enter the wonderful stage of puberty, where we develop secondary sex characteristics. Your primary sex characteristics are the reproductive systems and organs that you start life with, either having ovaries and uterus or penis and testes. And usually people have one or the other, not always, but usually we have one or the other. With secondary sex characteristics, we have non-reproductive sex characteristics that begin to develop. Things like when a man's voice drops, when a woman develops breasts, a woman's hips turn, a man develops larger, denser muscles, grows taller. All of these things are the secondary sex characteristics, things like body hair, for instance. Cognitively, we enter this formal operational stage with Piaget. And then we also want to talk about Erikson's developmental stages as well. So we're going to talk about Erikson for a moment. With Erikson, we begin life with a sequence of four stages that tend to have to do primarily with our ability to start and complete tasks on our own, our ability to function. Okay? Industry, initiative, autonomy, those things that allow us to get things done, right? And we process these challenges as children and begin to develop our feelings of autonomy, our feelings of industry, and our ability to do things in a functional way. As we enter puberty, though, we begin to enter this idea of identity versus role confusion. Before puberty, we have sort of a duplicate of our parents that is us. Okay? Our parents give us the things that we're interested in a lot of times. Our parents give us opportunities. Our parents give us our beliefs. Our parents give us our thoughts and all the education that we get, and we can't pick and choose. But as we enter puberty, as we enter formal operational thought, we can begin to determine who we are. And so children begin trying on a variety of identities in order to establish what they want to be. Okay? And ideally, parents should encourage this, but often don't, because the parents want the child to be a miniature version of themselves. Identity versus role confusion ideally ends with a fully formed and complete identity, but doesn't necessarily. Identity versus role confusion can also end, for instance, in what we would refer to as identity foreclosure. This occurs when a parent or role model has essentially put their foot down and said, this is who you will be. This is what you will do with your life. Oh, well, you're going to be a lawyer, and you're going to marry this person, and you're going to have these kids. And what ends up happening is that instead of developing a fully formed identity, the child gets this rigid mask of identity that is essentially a duplicate of the parent. As they grow, this identity can't continue to develop and can't continue to grow, and begins to fracture as more stresses are placed upon it. And eventually this false identity, this foreclosed identity, fractures and breaks, and we end up having what we refer to as often as a midlife crisis, where this adult now has to deal with this identity crisis that they should have dealt with as an adolescent. Now they have to deal with it when they're 40, 45 years old. And essentially what's happened is they don't have a model for who they should be when they don't have children anymore. So their identity fractures because they don't have a model for it. They never knew their parents when their parents didn't have children. So they don't have a model anymore. So this identity fractures and they have to form an identity at this very late stage. It's important to note that with Erikson's psychosocial stages, particularly these older stages, these adult stages that he gave us a series of ages for them, and they're not necessarily the truth. Identity versus role confusion actually does continue for the rest of our lives at a lesser rate. Every time you get a new job, when you have kids for the first time, when you get married, your identity changes and your identity grows. And so we develop these new identities, okay, and add them onto our complete identity structure. And that's part of why you have to have this complete, flexible identity structure rather than developing a false or foreclosed identity. Intimacy versus isolation. Erikson talked about that as the choice to get married or not, but that's not necessarily the case. Intimacy versus isolation also deals with whether or not you want friends, whether or not you want to live out your life in isolation. And intimacy versus isolation is one of those, is really the only choice that Erikson has, that either choice can be healthy. Most people need, or everyone needs, a certain level of intimacy, but for instance, what I consider, intimacy, what I consider a lot of friends, some people consider very, very few friends. And that's simply how I deal with the world in a relatively isolated fashion, whereas other people need a great deal more than I do. So, and it depends, and it's something that you deal with over and over and over in your lifetime. Generativity versus stagnation. Essentially, this begins when you begin to leave something for the next generation. When you begin to look at the world and say, I need to leave something behind, right? I need to generate something that will live beyond me. Okay? Versus stagnation, when you essentially allow yourself to stop developing. Okay, that's your stagnation period. And then integrity versus despair occurs when essentially it begins when you realize that you are going to die. As an adolescent, it's very difficult to conceptualize this. We sort of have this idea that we'll live forever. Even if we don't express this idea, life is like super long and we don't have to worry about it. As you get older, as you get closer and closer to death, we begin to recognize the inevitability of this. And so we have to fight this battle, sort of. Are we going to maintain our identity integrity or surrender it to despair and stop trying? As I mentioned, these ages that Erikson gave us become far more unstable as we grow and develop. And things like isolation, stagnation, despair, these things can strike at any time and will often strike multiple times throughout a person's life. We actually don't know why we age, why we physically age, why our body continues to age and deteriorate after puberty, because it should remain fairly static beyond then. We have a few theories. The first of these theories is a cellular clock theory, and this suggests that our DNA actually has a clock built into it, that there are sequences of code at the end of each of our chromosomes that break down as we get older, that causes our bodies to begin to slow down and eventually deteriorate as we get older. There's also the wear and tear theory, that the more mileage we put on our body, the quicker it wears out. This sort of goes both ways. There is actually a point where putting a certain amount of wear and tear on your body actually helps maintain it over a period of time, but putting too much wear and tear on your body does cause a certain amount of premature aging. We also have the free radical theory. The more free radicals you get in your system, the more damage it causes to your body. And free radicals can be as simple as, for instance, oxygen. Oxygen is actually toxic to your system and begins to break down DNA and cell walls and sorts of things as it interacts with your biology. And so we have to begin to, or we accumulate what's called antioxidants. And you hear that, oh, well, this food has a bunch of antioxidants. Well, that's why. These antioxidants help trap free radicals like oxygen in your system and prevent them from damaging your body. And all of these theories have credit. All of these theories have evidence to support them. So it's very possible that none of these are a single system that would cause this long-term damage to the human body that causes deterioration and eventually death, but rather all of them together help cause this deterioration over time. As we age and develop, there are a number of psychological disorders, autism, schizophrenia, conduct disorder, that we refer to as developmental disorders, right? And some of these, things like schizophrenia and conduct disorder, they can actually be mitigated by what we refer to as resilience or defensive factors that help you deal with the negative consequences of stresses and disorders in your life. Things like your social structure, for instance, gives you extra resilience. Having good friends, people that you can talk to, people that you can discuss your emotional health, your stressors with. These things provide you with resilience against against a variety of psychopathologies.